And as the first of these series, we are organizing yet the first work group of the Commission for this webinar. This work group is on multidimensional modeling. Today, we will speak about CityJSON. CityJSON is a JSON-based encoding for storing 3D digital city models, or digital maquettes or digital twins, as we say now. I'm the co-chair of the Working Group 1. My name is Ümit Işıkta. We have two distinguished speakers today on this webinar. Dr. Ken Arroyo Ohori, who is a postdoc researcher in 3D Geoinformation Group in TU Delft, and also he's serving as the secretary of Working Group 1 of Commission 4. And we have Stelios Vitalis, who is a PhD candidate in 3D Geoinformation Group in TU Delft. So both our speakers are from TU Delft, and welcome all. Welcome, Ken. Hello.
Welcome. Thank you very much, Ümit, for the introduction.
And welcome, Stelios. Hello.
Hello, welcome. Thank you.
And we'd like to welcome again their participants coming up, and we'd like to welcome everybody all around the world. This will be a two-stage presentation. First, Dr. Ohori will speak about the basics. He will give a general introduction to the subject of CityJSON. And then Stelios will provide information about the tools they have developed in their work group in TU Delft. So I hope this will be a fruitful webinar for all of us, and for all listeners of the webinar. So without further ado, I would like to give the stage to Ken. And Ken, the stage is yours, and hope you enjoy it.
Thank you very much, Ümit. Let me share my screen then. Thank you also to everyone for attending this webinar. As Ümit mentioned, Stelios and I would like to talk to you about CityJSON today, JSON-based encoding for storing 3D city models. To start with, let me introduce 3D city models for those who are not familiar with them. These are digital representations of the environment. These are mostly of urban areas, but even though it has city in the name, actually it can be applied to all sorts of places. There are some key distinguishing features, like you can think of them as a sort of 3D shapefile, storing polyhedra and surfaces. So it's not only points, like a point cloud, but you have actual objects. These are semantically defined, here shown in different colors. So you can see buildings in white, roads in gray, water bodies in blue, and green areas in different shades of green. And to each of these, you can attach a sort of attribute. So for instance, you might want to have a building and you want to store what is the height of the building, or what is the population of the building, like how many people are living there. And these can all be attached as attributes to specific city objects. In turn, when you look inside one specific city object, like in this case, a building, you have what are called semantic surfaces. So there is a sort of subdivision where you have a city object, and this is subdivided into surfaces based on the semantics. Like here, you can have the roof, you can have the walls, you can have the floor, and in turn, these can have their own subdivisions. Like maybe you have specific windows on the certain wall, and also you can have specific installations in a house. Like you can have balconies, you can have chimneys, and these are all labeled specifically with some sort of semantics. The idea is that if you do this for an entire city, you do this kind of standardized modeling for different cities around the world, you can build different kinds of applications. And because you do this in a standardized way, you can take a generic 3D city model that was built for any city and you can do some kind of spatial analysis to obtain something useful. For instance, here we have a few different applications, but like visibility analysis. So if you are standing in a window, what would you be able to see from this building? It doesn't have to be already built. It can be something built in the future. And you can think of applications like in some countries, based on the landmarks that you're able to see from a window, the value of a property can be higher or lower. Also now, it's very popular to install solar panels on roofs. And for this, you can do solar potential estimation. So you can find out how much energy would hit the different parts of the roof of your house, depending on where the solar panels would be located in it. But there are also many, many kinds of applications. So you can work with energy, you can do emergency response, like how to have emergency teams reach your house best. You can map utilities, so not only things overground, but also underground. You can estimate shadows cast by different buildings. So there are sometimes standards for how much sunlight certain house should get. You can register properties in a 3D cadastre. You can analyze noise. And for instance, now in our 3D information group, we're working also with computational fluid dynamics to analyze how wind affects cities. There are many possible applications. So going a bit into how this works in practice. So there's an existing 3D city modeling standard called CityGML. And CityJSON is a sort of encoding from it, because when you hear CityGML, you're actually talking about two different things. So with CityGML, there's a data model, and there's a specific encoding in XMGML. In our research group, we have found that the data model, which tells you like what sort of city object you have and how it's structured, it works very well. But if you are a developer or a user and you want to work with the GML encoding, it's actually very, very difficult in practice. So we are trying to achieve a better balance with CityJSON, taking the best parts of CityGML, the data model, but to work with a simpler encoding that we think is better for both developers and users. That was very vague. So what exactly is not in our view problematic about the GML encoding? And to start with, for end users, you end up with inconsistent software support sometimes, because since there are many possible ways to do things in GML and in CityGML in particular, developers need to support every single possible way to do these things. Otherwise, you end up with inconsistent support. And that's something that happens in a lot of software in practice. So also XML and GML is very, very verbose. So 3D city models can be many, many gigabytes in size, which can have computational issues. For developers, GML parsing is also a famously nasty problem that you cannot easily attack, like with regular expressions or some simple tools. There are also like links, X-links between different features, which are sort of complicated. GML is also not really built for the web, partly because it's very verbose, but it's also hard to parse and doesn't really have direct support in many things. And in CityGML, supporting extensions for developers requires extra work. So if you have an extension, let's say for energy, your software needs to have specific support for the energy ADE in order to have for it to work well. And that's something we try to avoid with CityJSON. So what do we offer instead in CityJSON? Everything is fully online and fully open. You can find everything in the CityJSON website, which is cityjson.org. Everything is easy to understand. There are examples, and maybe you can contrast that with the CityGML website, which hasn't been working for several years. We try to have everything online first and openly. We also offer a series of tutorials for users from very basic things like how to download, open files, how to do simple editing. And we try to do the same thing for developers. So in our 3D information group, we work with CityJSON both directly and through our students. And whenever we come up with a problem, something that we consider is very hard a bit hard at least to understand, we do it ourselves, and we also write a tutorial so that it's easier for other developers to also follow our steps. This is a sort of example. So you can open a CityJSON file with only a few lines of code. If you're a developer, you just need a JSON parser, which is basically built in basically every high-level language, high-level programming language. These lines of code with that are only like less than 10 lines. It's opening a file, parsing it, and telling you how many city objects you have and all their IDs. So you don't need custom libraries to open and process a file, unlike with the GML encoding of CityGML. And for everyone, we also offer all the specifications in detail online. Everything is available on the CityJSON website. There are examples for all city objects, how to encode things, how to deal with coordinate transformations. All the key elements are there, and it should be pretty easy to understand. And also, since everything is available online, you can post an issue if you have comments or problems, and we would be happy to help. More concretely, with CityJSON version 1.0 is out since April 2019, and we will have version 1.1 soon. All the development is done openly on GitHub, so you don't need to form part of a specific group in order to have access to it. Everything is open. If you like or don't like how certain things are going, please post an issue and we can discuss. All the modules from the CityGML data model are already available, the ones you have, you can see here on the right. So buildings, roads, railways, water bodies, everything about green spaces, bridges, tunnels, and groups of different city objects. There are plenty of tools available, both open source and commercial, and that includes everything from conversion to and from CityGML, validation of files, viewers, and different sort of processing tools. And as I mentioned earlier, there's an easy mechanism for extension. Right now, there are extensions for noise and modeling and for point clouds. One of our students is developing something for building permits, and there are other extensions on the way. And you can find many datasets already available. This is a nice example from that has all the buildings of the city of Zurich in Switzerland. And recently in our 3D information group in Delft, we released all buildings in the whole country of the Netherlands. And these are all openly available, and you can download them in CityJSON, or in other kinds of files as well. Yeah, and as I mentioned earlier, there's a lot of software that has already support for CityJSON. We maintain a list of these pieces of software in our website. You can see here both things that have been developed by us and also commercial tools, including FME. These already have support for CityJSON. And if you go to our website, you can check what is available in order to fulfill different tasks. And since software is for CityJSON is easy to build, we also encourage you, if you're a developer, in order to create something that works with CityJSON. In our experience also with students in Delft, we have seen that it is very easy for them also to start working with 3D city models in CityJSON, both for even for small projects in courses or for master thesis. So if you have any issues, please also let us know and we would be happy to help. And with this, I would give the floor to Stelios, who will talk to you in a bit more detail about what is inside the CityJSON file and show you some demos.
Thank you very much, Ken, for your very nice presentation. Without further ado, I'll just leave the floor to Stelios, and Stelios will carry on. Stelios, the floor is yours.
Thank you very much. Hope you can see it. Thank you. Yes, you see it. So, yeah, I'm carrying on what Ken said. So this is how a CityJSON file looks like, approximately. So if you ever open the CityGML file or a GML file in general, I think you can already see that it's kind of easier to comprehend some things. I'll go through them one by one later on, just to get a glimpse of it. But first, I would like to introduce the concept of LOD, which hasn't been discussed before. So if you're new to the concept of 3D city models, we have this level of details notation where for different kind of geometries, we describe them with a number. So because as Ken said already, you have different kind of applications and every application has different needs. That means that we need sometimes more details or less details. And it's not always that you need more details in a 3D city model. So according to the CityJML standard, the data model, there's this notation that LOD0 means that we have buildings, for instance, that they are just footprints. LOD1 means that we have buildings that they are prismatic shape, so a footprint that is just extruded. LOD2 means that we have some basic shape of the roof. LOD3 means that we have more features on the roof, or windows or doors around the walls. And LOD4 means that we have the interior. In practice, we never had any file of LOD4, but it's still there. And one of the nice things that we try to promote with CityJSON is that we try to promote a more complex LOD scheme that has been proposed by Philip Bilecki. So the notion here is that we have a different level of complexity on the horizontal and vertical level. And based on that, you can have not just LOD0, 1, 2, or 3, but you can have 1.2, for instance, which in this case would mean that you have more complex horizontal geometry, so more features there, but you don't have as much detail on the roof. And you can also see it with LOD, I guess you can see my cursor. So with LOD 1.2 and 1.3, you see more of a difference where you can have still prismatic shapes, but at least they are divided in such a way that you can still do some basic analysis for big changes in roof heights, for instance. And for 3D bath, those notions are going to be useful. So we'll come back to that later. So this is how a CityJSON file is. It's just a JSON snippet. So that's an object of type CityJSON, and it always says which version it is. That's a basic thing. Then one of the nice features is that we have support for enhanced metadata. In this case, we only have the reference system, but CityJSON can also contain a lot of information about the source of the file and its lineage and all these things. And I think you will see that later on with 3D bath, which also paid a lot of attention into storing this metadata there. Then there's a part of the CityJSON file which has the city object. So every of those buildings that we were talking about before, it is its own city object, its own entity that contains, well, the geometry and the attributes. And in that case, you can see that here I have an object of type building. We can have the other modules that Ken said about before. We can have roads, waterways, terrain, and all these things. Here we have a building, and these are the attributes of the building. So this means that the whole building has a measured height of 22.3. We have the roof type, the owner, etc. And then every geometry, every city object has its own geometry. And one of the features that we try to embrace there is we try to get best practices from the graphics world. So in 3D graphics, what normally people do is that they don't just repeat coordinates, but they have this indexing mechanism. So if that doesn't make sense for you, for users, normally that's not an important thing. That the point there is that we try to minimize the space that the CityJSON file uses from your disk. And this is also useful when you're trying to visualize data. And that's why it's easy to develop software like viewers and stuff. And then they support in the CityJSON file for appearance. So except for just having the geometry, you can also have some information about how the geometry looks. And that means we can have textures, and textures can be either the facade of the walls and how they actually look, or it could be the outcome of some simulation, like a continuous phenomenon could be shown through a texture that is wrapped on top of the surface. We can have materials. That means that we have some kind of a solid color or attribute along all the vertices, and this is supported by CityJSON itself. Then there's also the internal mechanism of linking. So there's a hierarchy in CityJSON. That's the same in CityJML. But here we flattened the hierarchy somehow. And the idea is that we can have building and building parts, and the building parts could be under the buildings. And I'm going to show an example later on to understand this better. But we are doing this through linking. We have this parent-child hierarchy between objects. So there can be objects that are parents, and they have certain children that are below them, and that keeps some kind of a ownership relationship between them. So that being said, I think I'm going to stop sharing the presentation, and I'm going to go through exposing my whole desktop. And hopefully I can push this on the top. And I should just start with this. So here's the CityJSON website, and you can visit this to get all the information that we said before. You can see the specification, using information. But I would like to visit the dataset so you can get some example datasets. And if you want to play with some dataset, you can already do it alongside me. So as I'm working on with this, so I could download the Den Haag dataset. You can save this somewhere in the downloads. I'm going to replace it because I already have it. And then there are a couple of software. There's a lot of software to visualize that. I'm going to show you a couple of them here. So one is Azul. Azul is only available in macOS, but you can find it on the App Store, or you can just find it on GitHub and download it. And it's pretty cool because you can just drag and drop a file there. In this case, this is the file that I just downloaded. This is the Den Haag dataset. And you can already see the geometry of it. And now on the left, I can see the different objects that are composing these data sets. So they're building and building parts, in case you can see. I hope you can see it. And I can select individual entities by double clicking here. So, and as I select them, I think at the bottom left, you might be able to see that they're the attributes of that. So the attributes that we said before, we saw the snippet, these are now listed here. And here we have a roof type and some information about the height. And what's interesting here is we can also go through the individual surfaces. So this is what Ken meant when he was talking about the semantic surfaces. So if I zoom into this object and I rotate a bit, I guess you can see that I can select the individual wall surfaces. This is probably one that is adjacent. But here you can see that the individual surfaces that compose this object, that bound this object, they can be selected and they can have their own information. So in that case, you just say which type is it. You can see that we have the roof surface, we have the ground surface. I guess we go from the bottom. But you can also have certain information there, like if you do some kind of simulation or you want to store some information that could be cadastral information, anything that is per surface, this can be stored there. And in case you don't have macOS and you don't want to install your own software, then you can also use Ninja. So if you visit ninja.cityjson.org, this is the official viewer for CityJSON that we have developed. It started as a student's project, so they started as a toy, and they saw how easy it was, and then we just took it and we tried to build a more comprehensive user interface to highlight also the semantics of the data set. And again, we can see the same model here. In that case, Ninja doesn't support semantic surfaces, so we only see coloring based off the different type of objects. And here we see all the buildings and we see the terrain that is there. Again, we can double click and we can select a specific object. But what is interesting here, I think we can see the hierarchy that we're talking about before. So Den Haag happened to use this hierarchy, and they have this notion where there is, for instance, here we can see that I select one object, which is a building, and this building has 3 children, and the children are building parts. And as I select them, maybe you could see that those objects are being selected here. So 1, 2, and 3 objects compose this specific building. And of course, every object can have its own attribute, as we saw before. And we can also see what kind of geometries they are supported there. So there are different kinds of geometries. In CityJSON, there can be multi-surfaces, which means just some surfacic geometry, or there can be solids, which means there's a bound volume by it. Now, you can always use Ninja. You can just visit it and drag and drop every file. So you can just, I hope you were following along, or you can do it on your own time. But one of the things we can show is also for 3dbug. So 3dbug is a project Ken talked about before. It has been developed by our group as well, and we built 3D buildings for the whole of the Netherlands. And if you remember the presentation I showed before, we developed 3 different LODs, LOD 1.2, LOD 1.3, and LOD 2.2. So this is the LOD 2.2. This means detailed roofs and everything. You can see LOD 1.3. That means prismatic surfaces, but still divided in a sense that makes sense. So the whole building have different prismatic geometries, or LOD 2.2, where we just have, LOD 1.2, where we have one prismatic surface, so one height horizontal for the whole object. And one of the cool things you can do if you're interested into the Netherlands, you can always download this data set. And by looking at the attributes, I can just click here to the tile number and I can download this JSON file myself. And after I download this file, I would like to show you, except for visualizing it, how many other things you could do. So first, I'm going to open it with Azul again. So that doesn't help. Yeah. So first, I'm going to show it Azul to show you that here we have the different LODs together. So before we had one LOD, but now you can see that there are different LODs bound together. And that's kind of annoying at this point, but it's also useful because we know that for the same building now, if I open this building on the left, you see that we have the 3 LODs, LOD 1.2, LOD 1.3, and LOD 2.2, right? And 2.2, for instance, does have semantic surface, as we said before, so ground surfaces and wall surface. Well, there are a lot of surfaces there, but yeah. While LOD 1.3, for instance, doesn't, or 1.2 doesn't, right? And again, as I said before, and as Ken mentioned in the beginning, different applications might need different things. So is there an easy way that we can extract the LOD that we need for the application that we want? So here is where we could use something like CityJSON. So CityJSON is a tool that we have also developed, and it's command line. So you don't have to use either the terminal if you have Mac OS or Linux, or you would have to use a command prompt if you're on Windows. It's based on Python. So all you need to have is you need to have Python installed, and then you should be able to just type pip install CityJSON, and that would install CityJSON. So as soon as you have pip, I'm not sure if it will work with Conda, you will have CityJSON. And after you install that, then you will have this command line tool that lets you do a whole bunch of things. And by typing CityJSON just as help, you can see all the different things you can do. Here are the commands. So we can do a lot of things here. We can remove textures. We can subtract a part of the file based on the bounding box. We can update the metadata, get the metadata. In our case, let's start by taking the file that I just downloaded. So you type CityJSON, and then you drag and drop your file that you just downloaded, and then you can just type info. And this is enough to get some basic information. So now I know that this is CityJSON version 1.0. I know what CRS this is on, and the bounding box that surrounds it, and whether it's compressed. That's a technicality that maybe you don't care that much about. What kind of objects are there? So we know that we only have buildings, for instance, here, and we have 436 buildings. We don't have materials, and we don't have textures. And since we saw that we have a lot of LODs, let's do something meaningful with that. So instead of just taking info, let's just extract an LOD. And in that case, I want to extract only the LOD2. So I want to only have the detailed version, and I'm going to save that as LOD2.json. So CityJSON is this pipeline, has this pipeline format where I can just send one command after another. And in that case, I will just extract an LOD and I will save the outcome as LOD2.json. So I guess that should be here, this file that I just created. So I could close this from Azul and drag and drop my new file. And now you see that I only have LOD2. In a simple fashion, I could have subtracted a portion of the area Or if I had more complicated data sets like the Hague, for instance, I could filter only buildings or only terrain and stuff. Now, if you think that's a bit complicated for you, don't worry. There are some ways that you can do this with other tools. But CityJSON is the most comprehensive way of doing it because this is what shaped with CityJSON itself. So since we have this, we could also check with another tool that we have developed on our group, and that's about 3D. And you can visit it in this web page. Now, this is the web version, and there's also a command line version. I'm going to show you the web version because, well, it's easier to do so. And you can validate your geometries using that. So I can go now there and just pass the new file that I just created. And I'm going to upload and validate my file. And now this is going to analyze the geometry and find for problems that might exist there, like self-intersecting geometries and stuff. And now I can see that there are some errors, how many primitives there are, and how many features there are, and how many are invalid features. And I can close the full report. And now I can see one by one for all my buildings, which ones are valid and which are invalid, and which kind of errors exist. So this is a very good tool that you can use to verify that your geometry is valid or not. Now, you can do the same from command line, but this is only for the geometry. Now, what you can do also with CGIO, to push up and down, what you can do with CGIO is that you can take the file that I just had, and you can validate the schema. So, as I said before, there's a data model, and the data model dictates how the schema should be. So, how many attributes you have, how many geometries are allowed, which geometries types are allowed, and all these things. So, with CGIO, you can quickly validate that. Well, not as quickly as we wished, because this is Python, but still, and we're working on having faster ways of doing that. So this is now going through the schema and the definition of how CityJSON file should be, and it's going to inform me about any possible issues that might exist there. So we validated the geometry, and now we validate the schema. So this one is a valid file, so that's the important part. Everything seems to be in place, but there are a bunch of warnings, and the warnings are fine. They just inform me that there are some attributes that they are not prescribed by the standard, but that's fine. That's part of the nature of CityJSON, is that we wanted to allow more freedom of expression to the users and the developers and the creators of the data sets. So here we have a bunch of attributes that they're not prescribed in some document, but that's still fine. If you wanted to avoid this warning, you could have developed your own extension, I can said before, and prescribe what those attributes could be so that people can ensure that when they fill this information, they are in the proper format. So now that we have this, I guess we have the file, we saw the file, that's fine, that's fun already. But the question is, can we do anything more meaningful outside of just visualizing? Can we somehow use this for other applications? And one of them is, of course, GIS. And thankfully, we've also developed a QGIS plugin, so you can import your 3D city model in QGIS and do some basic analysis there. And thankfully, QGIS now has these capabilities of visualizing 3D data, so you can also use it to visualize. So if you have QGIS, you can open it. It takes a while, but that's okay. And as I said, we have developed a Python plugin that you can download from QGIS itself. If QGIS works, I hope that's a good sign. Yeah, there it is. So if you want to have this working, you can go to plugins. So plugins, manage and install plugins. And make sure that you have all selected there. You can type CityJSON, and you will find CityJSON loader. And you can install this. I have it installed, but in your case, you will have the install plugin button here, so you can just install that. And as soon as you do that, you will have 3 different options to initiate that. You will have a small button here on the toolbar. Under vector, you will have CityJSON loader and the option to load the CityJSON file. And also through the toolbox, if you enable that, you will have it here. So you see CityJSON loader. I can even just search for CityJSON and you can find it. So I suggest that you use the toolbox. Sometimes it might be unstable, but it has the most options. And in that case, I could just load the file that I just created. So I could go Dropbox and CityJSON. I have the LOD2.json file. And there are a bunch of options that I can have here, because the problem is, as we said before, CityJSON has this complex hierarchy, and but QGIS doesn't, right? It has this flat idea of like everything is in one place, no hierarchies and everything. So before you do any kind of analysis, you need to decide how you want to process your data. Do you want to process your data per city object, or do you want to process the data per surface, right? So the options that you have is that you can divide the different object types in different layers. So you can have buildings in one layer, building parts in another layer, terrains in another layer, etc. We don't need that here because everything is a building. Then you can decide if you have a multi-LOD dataset. If you have the original dataset, for instance, we could ask that we load everything in one layer, but we have the LOD as an attribute, or that we have them as different layers. In that case, we only we got rid of the other LOD, so we don't need that. And then you can choose to have the semantic surfaces divided. So that means that every feature, every line in my QGIS is going to be one surface. So I will not be able to select the whole building, but I will be able to select the individual walls or the roofs, the roof surfaces or the ground surfaces. And I want to load that, and I want to load this as well, where I'm going to style everything based on that. I could force a specific reference system. I can force the one from the Netherlands, and you can filter by extent. So if you want, you can select only a small part of that. And the Dutch cadastre, for instance, releases those huge files, and you couldn't load them. So there's an option here where you can just say, I want this portion of the dataset to be downloaded, or you can filter only for specific objects. So you can load individual modules, like if you have, again, different types of objects, but you only need buildings, or you only need the thin reliefs or the terrain or something like that, then you can filter it here as well. Then I can press run, and then it loads the file for me. And now I can open the attributes table, and I can see all the individual surfaces, even mentioning what kind of surface there is there. Now, this data, though, we only see them here as 2D, but they're actually 3D. And thankfully, QGIS has a way to visualize 3D, so we can start a new 3D map. And as you can see now, the data are in 3D. I hope the window is not too small. And yes. And you can even identify individual surfaces and everything. And you can get information by clicking there. Okay, so can we do something basic with that? Well, we can go to the toolbox, for instance, and we can extract only the ground surfaces, right? So as I said before, if we look at the data again, there's one column which is the semantic surface, and we have ground surfaces, wall surfaces, and roof surfaces. Let's say we want to have the footprints of the building, so we can extract by attribute, and we can say that we want our semantic surface to be of type ground surface. Now, in a similar fashion, you could load all the buildings, and you could say that, for instance, you want to select only buildings of, let's say, roof type something, right? Depending on the attributes that the dataset has. So I can run this, and as soon as I have this, I can select nowhere. So, and now I only have the footprints. And now it's kind of annoying because this data set happens to be triangulated. So there's a way to buffer everything by 0. And that's an easy way of dissolving stuff without losing the attributes. So I will buffer by 0 and square. Again, I'm just giving an example of some things you can do. And now I really have the footprints of the data set. And the attributes remain there, and I can do some kind of analysis. And then I could even save this data set to any other format, so I can export everything as JSON or GeoPackage or a shapefile or whatever, and then I can use it in any other kind of software. And again, you can do this in different kinds of analysis. You can do it per surface, you can do it per city object, etc. So that's one thing with QGIS. If you're in the GIS world, and you can use this, I guess, as an input to even, if you have a terrain, to produce a DEM and do some kind of hydrological analysis or things like that. And for the people that might be interested in architecture or more in 3D graphics in general, we have also a Blender plugin. So the Blender plugin has kind of a funny name. It's called Up3Date. Again, that's a project that started by a student, and you can already see a pattern here that we either force students to do stuff for us, but also it means that it's like, this is also interesting for students, and they know how to do it. Actually, this student was super enthusiastic about this project, and he had his best life. We also helped him later on. This is the plugin for Blender. It's called Up3Date. You can just download a zip from GitHub if you found it. And then you can go to Blender itself, and you have to install it. I won't go through the process of how to install it because we are soon running out of time. So I'm only going to show you that after you install the plugin, you're going to have an option to load the CityJSON file here. And in my occasion, I'm going to go to the file that I just had. So the CityJSON LD2. And now I have everything here. What's even nicer is I have things grouped per LOD, so I could turn on and off the different LODs. In that case, we have LOD 2.2. If you're wondering where the data is, it's because we haven't zoomed yet. So there's an option of frame mode, and you can just zoom everywhere. And there's this feature of clipping here. I'm going to get away with this, like just forcing it to show me a better field of view. And I can see the whole data set, as you can see. And that's really cool because I can select the individual objects. The attributes are also there. I think they are in the object level. So you can see the LOD and the solid here. So the geometric properties. And then you can even edit the object yourself. So there's an edit mode. Well, Blender is not maybe the most easy to use software, but it definitely is very powerful. So you can use that. For instance, in this case, I could just scale this 2 times towards the Z-axis, for instance. And then the plugin also supports some export. So you can save this as a new file if you made any interesting change there and use it further for whatever analysis you want to use. So that's if you are into the architecture domain, maybe you can use that. You can export it as OBJ or whatever else you might need. You can import it into 3D Studio Max or Maya or whatever kind of visualization software you want. You can also load IFC models there, although IFC models can be complicated, but you can still load them in Blender. There's also a GIS plugin for Blender. We haven't checked how well it plays with everything, but still that's an option that you can always go through Blender and edit your geometry there. And one last thing that I would like to show you is something that we're playing for right now. So if you're into data science, there are bunch of libraries out there like PyVista or PyMesh, where you can load your data and you can do certain analysis. Like here, we are trying now to have this research where we compute stats and a bunch of things, and you can see that I can easily load data into PyVista. PyVista uses VTK if you know PyArgument stuff. And you can easily load the data, and you can do nice things like extract the individual features that compose these objects, so the feature edges, or you can do a voxelization through this library. And you can also compute a grid for this object, or in that case, we used another library and we computed the bounding box, the object-oriented bounding box, one of the many times to say the same thing. So it's really easy to manipulate the data in Python. I could show you the code, but it doesn't make any sense now. Initially, it was just like a few lines of code to make this work. And we're going to release this as well. So if you're interested in geometric manipulations through Python, soon you'll be able to find that. And I guess that's pretty much it. I hope that makes sense. And is there any questions?
Thank you very much, Stelios. It was an excellent talk and excellent work that you have done as a group of 3D geoinformation into Delft. Once again, sincere congratulations for very nice work and very interesting talk that you have presented today. We have several questions, so I will ask for using the order of the same order that they're asked. So this first come, first served basis. So we'll start from the first question. So any one of you, whoever wants to answer it, can answer it. So you're free to choose who will answer the question. Okay, the first question is, does Ninja support visualizing simulation results on CityJSON objects?
I guess
go ahead.
Yes, so I guess I could respond because I'm heavily involved into the development of that. So if something is stored as a CityJSON object, yes, it could be visualized. If not, no. But actually, one of the cool things that we realize now that we're playing with PyVista is that with PyVista, you can store things as VTK files, and then you can use them in ParaView. We're playing with this actually even today. So for simulation results, if it's anything like CFD or kind of continuous phenomena, you can use that. And there are some people that are working also the point cloud extension, and I don't know if they're interested into some kind of voxelization plugin, but yeah, that's for me.
Maybe I can add to that. Like it depends. There are different ways to store the simulation results. They can be stored as city objects, in which case it works in Ninja. They can be stored as attributes. It also works. If you store them as materials or textures, I don't think it works yet, but we are working on similar things.
Okay, thank you so much. So we are moving to the next question. So next question is, what is the research progress in terms of incorporating actual color information of the structures?
Maybe I can answer that. I think there are two different things here. Like in terms of the CityJSON data model and what's already there, CityJSON has support for incorporating the actual color information of the structures, either as materials or as textures. So as materials, you can store the one color per surface. And as a texture, you could actually take pictures, maybe like of the side of the building or the facade, and you can store that internally in the file as well. There are some cities that have this information available, but for the most part, this is maybe used more for visualization. And when people do analysis, they want to see the semantic information of the surfaces instead. So what is the use? Is it a roof or a facade rather than how it looks? So I answered the question.
Okay, thank you very much, Ken. We are carrying on with the next question. So I will quote the question. So in quotation marks, we are in the research journey to attain 3D city modeling, but I could only see building structures in CityJSON or CityGML. Can we generate CityJSON models of trees, drainage channels, street lights, manhole network, underground tunnels, cables, etc., which makes complete 3D city model?
Yeah, so for sure it's possible. Most of the focus is certainly on buildings, so that's what is most available, but other cities have modeled other city objects, like roads are also pretty common, water bodies are also pretty common. In terms of city furniture, certain cities have these available, and like city furniture refers to street lights, manhole covers, bus stops, garbage bins, that sort of thing. These are less available in practice, to be honest. I'm trying to open now an example where these are available, like in the city of Rotterdam. They have many of these available. One Let's see if this works.
Yeah, you can share the screen, Ken, if you like as well.
This is a bit slow. Yeah, so this is not working very well currently, but the city of Rotterdam actually has a 3D model of their entire city that includes everything, including like individual trees, benches. They have information about the roads, in addition to all buildings. So this information is available in certain places, and it's possible to model it if you have the information available. We have students in particular who have worked with modeling trees, different levels of detail. And Stelios maybe can tell you something about roads, which is also another interesting kind of city object.
Yes, so a couple of things. The first one is whether we can store these things, and the answer is yes, we can definitely store these things. And of course, Ken was also talking about whether we can find these kind of data sets. So certain people have tried to have this. There's I think the city of New York also has pretty much all the modules there. So they have roads, pavements, and buildings and stuff. So we can find some data, but not too much that they exploit this. One piece of research that we are working on right now is to make a complete model, at least with regards to roads and pavements and waterways and buildings. So we can incorporate both linear representation of roads, so center lines, and the surfaces, and whether we can use that for to extract some information like, let's say, the width of the roads compared to the height of the buildings as a ratio, which is useful for 3D urban morphology. But it's also one thing that we didn't mention. It's like there's a bunch of software that we have developed in the group, and one of them is called 3Difier. And this is an easy way to produce a complete model with most of these modules. So if you have a shapefile of your area with roads, land use, waterways, buildings, etc., and if you happen to have a point cloud as well, then you can combine those things, and you can make a model complete enough for your area. And that's what we're working for now. So we are making a 3D model of Montreal, for instance, and we're trying to incorporate also center lines and do some analysis there. But you can look at 3Difier. Maybe we can post the link.
Yeah,
and you can play with it.
Okay, thank you, Stelios, for the very nice response. Actually, the next question is more or less related with your response, actually. So the next question is, what kind of basic data you have taken, shapefile or what, and how to get the height data? I think this is more or less the similar topic that we have talked now, but anyone of you wants to answer it, please?
Well, there are two basic ways to get height information for generally buildings, but all sorts of features. Like you usually start from a point cloud, and this can be either derived from photogrammetry, so sets of aerial pictures, or from aerial LiDAR. In the Netherlands, we have the advantage that there is a publicly available LiDAR point cloud of the entire country. It's done through aerial LiDAR, which is the AHN. But if you don't have this available, easy answers are starting from like pictures from a drone or from individual measurements if it's just a building or two.
Can also, I think the question also, our attendee wants to learn also how to get the basic 2D footprints or something like that. What are your sources, or what sources do you advise?
Well, these are sometimes available already from governments, usually in the form of cadastral data. It's pretty common. If it's not available from government official data, you could also have a look at OpenStreetMap, which in many places has like building footprints available that you can download. Otherwise, you're more or less stuck getting these, creating these manually. Some people do it from aerial pictures. Otherwise, you just have to plot them manually, I guess.
Okay, thank you. Another question is about the QGIS plugin that you have shown us, Stelios. You can answer it or can. One of our attendees asks, so once you import the CityJSON into the QGIS environment, what type of analysis can you do, or what is the potential? For example, can you do a solar potential calculation, or what is the potential? What type of analysis can you do in QGIS with the data that you import using your CityJSON plugin? Application areas, what are the application areas, or in other words?
Well, I have to admit that we haven't worked too much on the application area of QGIS. One of the problems is that QGIS mostly assumes 2D or 2.5D geometry. So normally you will have, with the most of the toolbox, you'll have to assume that they will get some kind of 2.5D data. And in that sense, you can transform your data to 2.5D. So there are a bunch of solar potential analysis tools that are there. But you will have to convert your data set to a raster. So I guess you could take the roof types, for instance, and you could create by the elevation raster, so in the interpolation of that, and then you can use that as input to the solar potential tools that are there. There is network analysis that you can do as soon as you have a CityJSON file with center lines, for instance. Yeah, for the rest, you would have to assume that you have basic 2D analysis. So unfortunately, that's a limitation of QGIS. One of the things maybe is that I think GrassGIS is more powerful in that perspective, and QGIS has the GrassGIS toolbox incorporated. So we haven't tested thoroughly with that, but maybe that's one direction that one can test.
I can add to that. So indeed, in Grass, you can do basic solar potential analysis. I think it's if you do the r.aspect function, for rasters, you can start to compute it. And also in QGIS, there's compatibility with Saga. And I know that Saga has a solar potential analysis function built in, although I haven't tested it personally.
Thank you, Stelios. Thank you, Ken. And the beauty of QGIS is being open source. So that's very nice as well. Very nice effort. Another question is about software implementations. One of our attendees asks, can CityJSON be added in ArcMap2? So can you visualize CityJSON in Arc S3 software, more generalized version of it?
I can maybe answer that. So not directly, but there is the data interoperability extension for ArcGIS, which is basically FME. It's a module that is based on FME, and through that you can indeed open CityJSON in ArcGIS.
Okay, thank you. Stelios, do you want to add anything to this?
Well, or someone can use QGIS, which is free anyway, and they can convert it to shapefiles or whatever kind of format, and they can just load it to ArcGIS.
Okay, thank you very much. We have another question. So, can I convert CityJSON to 3D tiles? Or is it efficient enough for large-scale visualization if I convert it?
I guess I can. Yeah, I have been involved in the 3D project, and we had to use 3D tiles for that. So the answer is no, it's not really the most efficient way of disseminating data, at least, right? So the point of CityJSON is to have comprehensive information, to have this hierarchy. So if you are interested in speed and stuff, then you would have to convert to 3D tiles. We don't have a direct converter, although I'm not sure as part of 3debug, there's something that has been developed there. But one thing I forgot to mention for 3debug is also everything that we made there is open source. So the whole toolchain of how we build the 3D models and how we disseminate them is going to be open source. And one part of that is how we create the 3D tiles. We don't do it from CityJSON, we do it from a database. Yeah, that's the only way. So you will have to do some kind of transformation. Maybe someone could use, for instance, QGIS in that perspective. They could load CityJSON files and they could store them in PostGIS. And there is one tool that is called PG2B3DS. Now, nobody's going to remember this name, but anyway, and you can convert them to 3D tiles. But yeah, CityJSON is not supposed to be the most efficient way of disseminating a lot of data. But if you convert to 3D tiles, you have the same problem that you have, for instance, when you load data in QGIS. It's like converting from CityJSON to a shapefile. Shapefile is flat. There's no hierarchy. There's no information of individual surfaces. So you will have to either choose to have too much information per surface, or you will have to just lose some information in the process. So you cannot do one by one.
Okay, thank you very much, Stelios.
Maybe to add to that, I think you can also use FME to do the conversion directly.
Yeah,
but I haven't tried it.
Yeah, yeah. Another question and comment. So one of our attendees says, "Thank you for this excellent presentation. I'm not a coder yet, so I wanted to know, how does one start for a city if there is no building data?"
Yeah, that's a difficult question.
Yeah.
It depends on what is available already. I would say the most standard way to start is to start from building footprints, maybe from cadastral data, maybe from pictures, maybe from measuring or mapping them manually. And for the height information, there are different ways to approximate it. Like a lot of people approximate it just based on number of stories, if you have that available. Otherwise, you can start just by assuming a uniform height and then slowly add the height information. Have a look, at least take a look at OpenStreetMap and see what's available there already. Even though you cannot see directly, many buildings in OpenStreetMap actually have 3D information.
Yeah.
If I may add to that, you can always be a bit creative. So, for instance, I come from Greece, and unfortunately in Greece we don't have such data sets, but it happens to be that OpenStreetMap did have for a few years, and I think actually OpenStreetMap has expanded a lot. So at least in my country, it has expanded a lot in coverage of buildings, so you can find the footprints there. And if you find any kind of digital elevation model or digital surface model, you can always convert that, and you can use that as a point cloud. You don't. If you use it with something like 3 to 5 meters, you don't need too much information there, and you can easily then extrude the buildings.
Thank you, Stelios. Another question, how can you manipulate or edit CityJSON files?
There are different ways. You can do it either directly in the text file, you can use Blender, you can use QGIS, you can use FME. If you go to the CityJSON website, in the software section, it tells you actually what software is able to do, what functions.
Okay, thank you.
I also forgot to show that Ninja has the capability that for every individual object, you can just edit the JSON snippet. So that's an easy way of changing stuff like small attributes and stuff. And that CGIO happens to be, except for a program, it's also a Python library. So if you're a Python programmer and you want to do some batch converting, you can always load data with CGIO and manipulate.
So you can add it through you can add it through CGIO as well as programmatically as well.
Yes.
Okay, thank you. Another question: like CityGML has an application domain extension, does CityJSON also has the same approach or ADE approach?
CityJSON has support for extensions, and they're actually much simpler to build and to use than the ones in CityGML. Like city objects, new city objects can be defined, and they are first-class objects. So, yeah, ideally they should work in all software. So, if you, for instance, I have a student that I'm supervising now, who's building stuff related to building permits. And you should be able to see this as new city object directly in any software that supports CityJSON. The schema for these extensions can be defined using JSON schema instead of XML, but short answer is that yes, it has support for the same.
Thank you. Another question. CityJSON could be imported in Blender, then modified. Could the modifications made in Blender be saved, exported into a new CityJSON?
Yes, yes, they can. So if you go to the export, there's also a CityJSON part there, and you can export the file. It used to be a bit slow, but we got lately from someone that was working in Slovenia in another project. We got some pull requests and they made it faster. So I think it's going to work fast as well. Yeah, so the student actually that developed that, they were doing this, they were importing things, they would change things, and they would test with different things.
Thank you, Stelios. We have another question. Also, a common use case is to convert 3D data from IFC-BIM. Can you suggest a pipeline to convert IFC-BIM to CityJSON?
Okay, so that's a very good question and sort of a complex procedure, to be honest. This can be done in a straightforward way with FME if you build your own workflow. But to be honest, this requires a lot of work in order to work properly. For an open solution, you can do the same based on IFC OpenShell. But yeah, the same thing, to be honest, this works only well for very simple buildings. It's very much a research topic that we and other research groups are working on to be able to do this conversion accurately and fast for big buildings.
Yeah, I think you will have several master's students on this or PhDs. It's a very interesting topic as well. I think the same. Another question. In the standards, which geometry accuracies have been defined for different LODs and sub-LODs? The accuracy of angular measurements has been taken into account and question mark. I think it's like, has the accuracy of angular measurements been taken into account? So this is the second part of the question.
Well, to start with, the LOD specification in CityJSON is actually flexible. So we don't prescribe any specific levels of detail. You're free to choose whatever you think is appropriate for a given application. We just link to the standard LOD specification inside CityGML, as well as the refined LODs defined by Filip Biliecki. So there is no specific accuracy taken into account for the moment, but you're free to define it. I know that this is, for instance, a very big issue when you work with BIM models, not so much with 3D city models. Yeah, if you have any specific insight into that, we would be welcome to hear it.
Okay, thank you.
And one interesting insight in that is that Filip Biliecki himself, when he was doing research on the topic, he figured out that actually this is not prescribed by the LODs, right? So the LODs are not supposed to be about the accuracy of acquisition or reconstruction. But one of the findings is that normally high LOD has more accuracy, but more validation issues. So this is something for people to keep in mind, that necessarily high accuracy is not necessarily better in all occasions.
Thank you, Ken. Thank you, Stelios. Another question. Can you please tell the basic step to create 3D CityJSON modeling? I'm having building footprint shapefile and UAV photogrammetric point clouds.
Okay, I think we have answered this question partially in the past, but I would like to point you to 3D Fire, the software that has been developed by our research group. If you have building footprints and you have a point cloud, well, not only building footprints, if you have a planar partition defining different buildings, but also like what is the shape of the roads, water bodies, vegetation, and so on in 2D, and you combine that with a point cloud that you have, with 3D Fire, you can create an entire 3D city model.
Okay, thank you. We have another question. Is it possible to model indoors using CityJSON? Okay, that's thank you for the question. That's another bit of a complex one. Like Stelios mentioned, LOD4 has been defined in CityGML for interiors, in theory, but in practice, nobody was really doing it. And there has been a lot of academic discussion on the matter because
there are no real LODs like for different levels of detail for the interior, which was a problem for a lot of people. When you jump to LOD4, it meant that you had like extremely detailed like architectural interiors, sometimes with furniture and so on, and that was not something that most people were ready to handle. Recently, there has been more discussion that the better way to approach this is to model things like stories, rooms, stairways, and so on, staircases, sorry. And in CityJSON 1.1, we have added the basis, at least the basics for that, and it should be released at some point in this year.
Okay, thank you. I think we covered all the questions. Can and Stelios, you can also see the questions. If I missed any, please let me know. I think we covered all. Cheryl also can check if we missed any. I think we didn't miss any. But
there's a new one.
Is there a new one? Okay, I think yes, there's a new one. Yes. What will be the future of CityJSON? Will it someday replace CityGML as a new lightweight de facto standard, or will it be more related to web applications?
Well, we like CityJSON a lot, as you have realized. In our view, it really fixes a lot of the issues with CityGML. There's some discussion whether we should stick to the CityGML data model or whether we should diverge a bit from it where it makes sense. I personally think that there is nothing that CityGML can do that CityJSON cannot do better, to be honest. So I would like to see it being replaced, but more honestly, they have a very different design philosophy as well. A lot of the people like us who work with CityJSON are both users and developers, and we have a different style of working. We want to have everything open through GitHub open discussion, and CityGML has a more traditional way of working and a way of modeling the world, so it follows older, more rigid standards, more closed organization. So we would maybe like to see CityJSON succeed entirely, but they're not entirely competitors. Maybe they're applications where one or the other makes more sense than the other. Stelios, do you want to add something?
Only the fact that, well, CityJSON has recently been approved as a community standard by the OGC itself, if that's something that is important for some people. And I think there was a discussion also that this was going to be incorporated as a de facto standard of 3D data for the Netherlands to replace the existing CityGML-based standard. So, but I think the point for us is that we want to do something that is applicable and it's fun to play with, and it makes sense to play. That's why we develop all this software. So, well, if the community really takes all the software and really uses it, then I guess it could replace it, but the community will decide in the end. So just have fun with it and we see.
Thank you. Thank you very much. I think we have finalized all the questions. If you don't have any new questions, we will finalize the presentation and finalize the webinar. Okay, so I'd like to first start by thanking to ISPRS Council Management Board. First of all, thank you very much for giving us this opportunity. And secondly, I would like to thank Commission for Management Board. Thank you very much for supporting us. And I would like to thank then our speakers, distinguished speakers, Dr. Ken Arroyo Ohori and Stelios Vitalis, who is a PhD candidate in TU Delft. So, and finally, I'd like to thank all our attendees, and ISPRS Student Consortium also helped us a lot in the organization. And I'd like to thank all our attendees, and I'd like all our attendees for attending this event and making this event a very fruitful one. And I'd like to thank everyone for joining the event, and hope we'll see you face to face once this pandemic is over. So looking forward to see you in face to face in ISPRS events when this is over, and hope it will be soon. Okay, so I'd like to say goodbye to everyone, and hope to see you soon face-to-face in ISPRS events. Thank you. Goodbye.
Bye,
Goodbye.
Thank you very much.
Elias.
Thank you.
Thank you. Goodbye. Goodbye.